Hello, everyone. So we are gonna have a ninth grade MathCON practice test today. So we have integer x and y, and we are given some inequalities, and based on this, what we are gonna find is just order pair number. Okay. So like the first things first, x and y is integer, so which is nicer to have. So the lowest we can get is for x is 3. If I choose x as 3, right? Then the inequality, the second one we will get is going to be 1 smaller than 3 times y, that is smaller than or equal to 60. So in this case, if I choose y to be 1, okay, that will be 3. If I choose 0, that will be 0. So I cannot choose 0. So then y could be, in this case, 1. If I choose 2, that does also work. And 3 all the way. If I choose 20, that will be 60. And then 60 is the largest number we can accept. So that means we have 20 integer for y value. So which means 3, 1, 3, 2, all the way to 3, 20 is good in this case. So far we have 20 pairs, okay? So the second case, like if x is 4 instead, because we can choose x to be 4 as well. So then the second inequality would be 4 times y is lesser than or equal to 60. And then y could be still like 1, 2, 3, 4, all the way to the 15, because 4, 15 is 60. So then you do have 1, 2, 3, and 15, right? So we have 15 numbers. That does also work now. And the last case that we have for x is 5. So if I choose x to be 5, if x is 5, right, then the 1 is smaller than 5y, that is smaller than or equal to 60. So the y could be 1, 2, all the way to the 12, because 5, 12 is 60. So you will get 1, 2, 3, 12. So then we have 12 y values for the x equals 5. So 5, 1, 5, 2, all the way to 5, 12. We have 12 numbers additional. So if you combine these, that's 35 and 47. So that's choice C. So that was the first problem. So I hope that wasn't too challenging. So let's look at the next one. So second problem, in how many ways can 3 different pencils, okay, so 3 different pencils can be distributed to 4 students so that every student gets at most 1 pencil. Okay, so make sure you read every single word in counting question especially, and this is one of those. So we want to make sure that every student will get at most 1. So, right? So for the first pencil, let's say we take one of those pencils and we just need to give someone, and now we have 4 people, right? So we have 4 options for the first pencil, so which is gonna be 4 ways I can achieve that. So let's say I give that pencil to person A, and now I have 2 more pencils left that I need to distribute, but I cannot give anything to person A anymore. So we have now 3 more people that I can choose another pencil to distribute. So if I have now 2 left pencil, right? So then I do have 2 options to choose. Like, let's say I got the pencil number 2, whatever that pencil, and then I'll give that to one of the 3 other people. So which is why we have 3 options for the second pencil. And if I just do the same thing with the third, then I do have 2 pencils left. So that should be total number of ways that I can actually distribute this, which is going to be 24, choice C. So some people may be asking, like, how about what pencil goes to person A, right? So, or what pencil like goes to person, I don't know, B or C. So in this case, we don't really care that, because our goal is that we just want to make sure that every student get either 0 or 1 pencil. So that's the problem is asking. So as soon as we achieve that, so we should be good, and that's just the answer. Okay, so 24. So let's look at the next problem. So number 3 is a geometry. So we have center O1, which is right there, and O2 is right there. They are tangent at point C, and O1, B, and O2 as well as C are collinear, which is they are on the same line. And the distance between the O1 to O2, which is like this distance, is 10 units. What will be the x, which is AB? Okay, so like we don't really know the radius of each circle, right? So I'm gonna call this is R, which means O2 to B is also R. And since I don't know about this piece, maybe I can label something else, but O1 to O2 is 10. So from this distance to this is 10. So which is why for this part, O1B, I can say this is 10 minus the radius of the smaller circle. Because I don't want to make another variable unless I really need it. So I just write this in terms of the smaller circle's radius. And if you look at this now, so we know that the radius of the larger circle, which maybe we should highlight a bit. So this distance from here to here, that's the radius of the larger circle. So from O1 to O2, O1 to O2 plus O2 to C, this is gonna be the radius of the larger circle. And the reason I just write this way, because I know O1 to O2, which is 10, and then O2 to C is just the R, so that's basically our capital R, which is 10 plus R. So which is the same as A to the O1. So I can say this is equal to A O1 because that's also radius of the larger circle. And the question is now asking AB. A to B is just what we want. That is equal to A to O1 plus O1 to B. And I do know AO1 is 10 plus R, right? And O1B, O1 is right here, B is right here. We already did this right here, 10 minus R, so that is 10 minus R. So the DRs will cancel, so we will be done with the question, which is choice A. So meaning that the R doesn't really matter. So if you couldn't come up with this idea, maybe you can just eyeball and guess the radius of the smaller one, and based on that, you can just find the larger one and see if that really works for different numbers. And if that does, then you can go with that for sure. But I think we don't need that, to be honest. This is not too challenge, okay? So let's look at the next one. So number 4, we have a graph of the function, so is given. And which of the following is a solution to this inequality? It says f of x, which basically y value, is lesser than 0. So if you look at the graph, so y equals 0 is just this line. This is y equals 0, which is our x-axis. So that is y equals 0. And we are looking for something lesser than that. So whatever that is below that line is gonna be our solution set, which is basically this region and this region. So we are looking for as an interval notation. So if you look at this one, this is -4 all the way to -2, which we have right there. So that doesn't work, that doesn't work. So we have right there, that doesn't work either. And also we have anything larger than 3, that's also works. So that looks like choice B. So it wasn't too bad. So as long as you know how to read the graph, so this was just asking where the function has a value that is lesser than 0. So that's just choice B. Okay, so here we have number 5. So we want to see which one is like bigger or equal to each other based on the given expression. So just use the properties of the exponent. So we have 3 to the 5th and 4 to the 5th. When you have same exponent, we may multiply the basis, which is like 3 times 4. So I can write 3 times 4 to the 5th power, which is 12 to the 5th power. And on the right side, we have also 12 to the 5th, so they has to be equal to each other. So that means this is not okay, and this is not okay, this is not okay either. So the second one, we have 3 to the 5th, 3 to the 4th, and 4 to the 7th, right? And we do have like 3 to the 5th and 3 to the 4th, and you can just try plug into calculator because we are allowed to do so. But if I wanna do something else. Like I can just multiply these two numbers like this way. So 3 to the 5th times 3 to the 4th can be written as 3 to the 2nd times 3 to the 3rd times 3 to the 4th. And the reason I'm just doing this because I like to write the 7th power of something. That's why I just want to play with that. And this number, the product of this part, so since we have the same base, I can add the numerator, the exponent. So that should be 3 squared, which is 9. And then this is going to be 3 to the 7. And this is the left side of the second part. But we have 4 to the 7th power, right? So this is what we are going to try to compare with the 4 to the 7. And the question is, if I kind of don't get anything right here. I was about to submit, like, try to see if this is like easier with the manipulation, but it looks like it is not looking nicer. So let me try this first, and then I'll try to see if we can come up with something on this space. Okay. So the next one, like we have 3 to the 4th and 4 to the 5th, and then we have 12 to the 4th. So I can multiply 3 and 4 if I have the same exponent, which is 4 and 5. I can make this the second one as 3 to the 4th and 4 to the 4th times 4 to the 1st power. Okay, so again, the 4 to the 5th can be written as 4 to the 4th times 4 to the 1st. And since these two have same exponent, I can multiply those bases, which is going to be 12 to the 4th power for these two, and then times 4. And on the other side, we have 12 to the 4th power. So this is 12 to the 4th, and then this is 12 to the 4th. They are equal, but we do multiply this by 4, which means the left number right here, this product is going to be 4 times as much bigger. So that should be larger for the last one. So this is good. And then this is also good. But the middle one is not really like sure, right? So maybe we can just multiply those just to see which one is bigger than the other. And if you do so with calculator, so you will see then the 4 to the 7 is indeed bigger than this product. So which is gonna be actually, yeah, 4 to the 7 is smaller than actually this product. So the choice C should be our answer. And if you don't come up with that, you can just multiply because there are not two big numbers. Because 3 to the 5th and 3 to the 4th is something we can handle by writing, but just try with calculator, okay? So that was number 5. Okay, so number 6, we have a number theory. So we are given different positive integer ABCs, and that's a variance inequality. And based on that, we want to find the minimum value of the sum. Okay, so since we have fraction, which is not nicer, so I'll just get rid of the fraction by finding their least common multiple of the denominator. So I see they are like 60 is the least common multiple. So I'm going to multiply this by 12 and this by 5 and this by 6 so we can get the common denominator. So then the inequality will become basically 12 times A over 60 that is smaller than 5 times B over 60 and then 6 times C over 60. Since we have the same denominator, so and they are also positive, so that means we do have the same inequality relation with the numerator. So 12 times A is smaller than 5B. That is smaller than 6 times C. Since we want to achieve the minimum, so let's start with A to be minimum number. That's 1. Because if this is a huge number, then the other numbers will be forced to get big number as well. So which is why we want to force A to be as small as possible, which is the smallest positive is 1. So we can go with that. And that's 12 already. That means this has to be at least 15 because it has to be multiple of 5. So that is 3. And then to get the something larger than 15, when you multiply by 6, that's 18. But if I do this, that is add up to 7, right? But we need to be careful. We are told they are going to be different. So which is why we cannot accept this one. We should take the next integer, which is 4. And if you add them, so you will get 8. But some of you might be asking, is it possible to get something smaller than this still without really using this maybe? Maybe we can try this too to see what's going to happen. If this is 2, that's 24. but you just double the number as before. So that means this number forced to be bigger as well. So the lowest number you can get 25, which means B has to be 5. That's already 7. So you cannot have anything smaller because that should be 1, but that doesn't work anyway. So that's why the 8 was the smallest we can get in this case. Okay. So that was the number 6. So let's end this part now. Okay. I hope that was clear. I'll see you in the next part.